Hello everyone. In this video, we will be discussing last topics in non-traditional machining process that is in module 1. So what are the topics we'll be discussing here is advantages, disadvantages and applications of non-traditional machining process we'll be discussing. So even though we have not discussed all the non-traditional machining processes individually, here we will be discussing the general, like advantages, disadvantages and applications we'll be discussing here. And based on like the comparison between the conventional machining process, or we can call as a traditional machining process, and the non-traditional machining process, lot many things we have learned. So just to be very quick and very fast, if I want to say means most of the the hard to machine process are like brittle materials, ceramics, glass, composites, and even different complicated like shape, size, interior designs. So all those things can be easily done in the non-traditional machining process. That too, we have varieties of non-traditional machining process, and even based on the energies we see, like combination of mechanical, thermal, chemical, electrical. Like we have a laser, we have many combinations. So all those things and all we have discussed. So it is even easy for us to write down the merits and the demerits of non-traditional machining process. We can able to write. Of course, the limitations will be very less, and without even discussing, I can say that the limitations would be probably maybe the capital investment, the maintenance, all those things, would be the limitations. But I can list down, like the enough advantages, and even the interesting part, that is the applications of non-traditional machining process. Actually, I can say, like based on this requirement only, this non-traditional machining process has arisen in the engineering field. So first, we will just quickly discuss of the limitations, as it is very less. First one is more expensive. Undoubtedly, we cannot compare the price of all the machining process with any of the conventional machining process, that is the machines, and the metal removal rate is very slow. So I said, like the surface finish, and even the accuracy, the dimensions, everything, shape, size, everything is fine. But comparatively, we will be getting the microscopic size of chip. So the metal removal rate will be usually slow. But if you are going with the many units of the machines, it is possible. Of course, the point to be noted here is all the investments what we are doing for the non-traditional machining process should be more. So usually the metal removal rate is slow, and there are three machining process. Like I can list it down as abrasive jet machining process, uh, plasma arc machining process, and electron beam machining process are not commercially economical process. It means like we cannot gain any profit, in the sense like the investment would be more, and even the type of product what we are making based on the different material, we cannot get more profits. So I can say, like the very few limitations, but we can but the benefits, if you see, like it is more. So comparing the benefits, we can compromise the limitations. Number one, it increases productivity. As I said, if you own a big company where the many units are there, say for example ultrasonic machining process, many units are there, and it may be the laser beam machining, many units are there, means productivity can be increased, and with the high like a fine surface finish, accuracy, size, shape, dimensions, everything can be achieved. If you are rich enough to invest or to own a company, means the productivity can be increased, usually in case of like a traditional machining process, where the highly skilled person have to work, and even if you make any minor mistake, the whole output it becomes waste. And moving to the next one, the very important advantage personally I feel, which is very important, that is it reduces number of rejected components, which is very common in the traditional machining process. That's what I said. Of course, 90 to 95% of the like the process would have done in the traditional machining process, but maybe in the last minute, maybe the intricate like the very fine details, maybe while doing that, maybe some mistake happens, but ultimately that gets rejected. So but kind of chances are nil in case of the non-traditional machining process, because 100% accuracy we can expect, and close tolerance is possible, which is again one more important advantage. Usually if you take any machining process like in conventional type, which is highly difficult, that is the tolerance closeness is very difficult, but is very possible, and it is even we can say like 99.99% tolerance is easily possible. Why I'm not telling 100% means maybe some errors due to the environmental and due to the quality of the material what we are using. Based on that, some error, that is 0.001% I can say. And the tool material need not to be hardened in the workpiece, which is the very important aspect to be noted in the conventional machining process. But here that is not the case. Moreover, here the tool is not at all touching the workpiece, so we need not to worry whether it should be harder or whether it should be sharper, or like whether it's an expensive tool. All those things doesn't matter here at all. And the next advantage, where the machine surface do not have residual stresses. Usually when you do in any manufacturing process in the conventional machines, where some residual stresses will be there because of more heat or more current, like whatever the things. But here such kind of things will not be there. And next one is hard materials can be machined easily. I can say like this should be the first point to be written in the advantage one. Anyway, like all the 6 points are important. Along with this, few more things also you can write it down after discussing the different processes. Definitely you people will be very much aware of the the major advantages of all those things. Moving to the last topic, applications of non-traditional machining process, like one by one we'll be discussing. First we'll start with the ultrasonic machining process, which is mainly used for drilling and machining cavities or holes in conductive and non-conductive materials like glass, ceramics, etc. And even the threading of various glass and ceramic materials is recommended. Lapping, broaching operations also can be done easily by using ultrasonic machining process. And moving to the second major process, abrasive jet machining process, which is mainly used for machining of brittle and heat sensitive materials like glass, quartz, semiconductors, mica, etc. And it is also used in drilling holes, cutting slots, deburring, removing oxides and other surface films on the workpiece, and removing glue and paint from paintings and leather objects. You can able to see like it, which is very complicated and very rare process, which can be easily done in the abrasive jet machining process. And moving to the third one, water jet machining process is almost similar to the abrasive jet machining process, but only some 20 to 30% is varying. While discussing this topic, we'll come to know what are they. And it is mainly used for cleaning operations, or killing of pathogens in beverages and drips, and cutting off printed circuit boards for electronics applications, etc. And the fourth one, electrochemical machining process, which is mainly used for facing and turning complex three-dimensional surfaces. Complex three-dimensional surfaces, usually electrochemical machining, as I said, where we will be masking the whole workpiece, leaving the portions where the excess material should be removed, and where the deburning, grinding, honing, cutting off, die sinking, profiling, tree panning, broaching, multiple hole drilling, all those things, processes is can be done, and which where electrochemical machining process highly recommended for all these things. And the material, workpiece material can be anything. And moving to the next one, chemical machining process, which is widely used for making a thin out wall, webs and ribs of parts that have been produced by forging, casting or sheet metal forming, which is also used for improving surface characteristics like elimination of the deburring layer from low alloy steel forgings, etc. And the last one, what we'll be discussing in our syllabus, electrical discharge machining, which is widely used for a process in aerospace applications to produce the turbine blades, nozzle holes and other parts, and in mold making and die casting to produce die mold cavities, small deep holes, narrow slots, stamping tools, wire drawing and extrusion dies, etc. can be economically machined with the electrical discharge machining. Next one is the plasma arc machining process, which is widely used for manufacturers of transportation and agriculture equipments, heavy machineries, aircraft components, and many other products which have discovered the benefits of plasma arc machining. And it is also used for sawing, drilling, machining, punching, and cutting operations, etc. And the next one, laser beam machining, which is used for automobile sectors, aircraft industries, electronics industries, civil structures, nuclear sector, and house applications, etc. And electron beam machining process, which is mainly used in micro finishing operations of thin sections, dies for wire drawing, parts of electron microscopes, fiber spinners, injectors for diesel engines, gas orifices for pressure differential devices, which is used in nuclear reactors, rotors, and aircraft engines. So these are some of the major applications. So whenever in future day-to-day life, if you happen to hear okay aircraft industry, or it may be agricultural equipments or heavy machineries like civil structures or nuclear sectors, means you can just easily remember okay which non-traditional machining process should be recommended. So with this video gets closed.